All right. Hello, everyone. Welcome to another live stream. Today, I am very excited to have with me Dhrumil. Dhrumil, how are you?
Hey, great.
Outstanding. So today's title, Observability is not ops. This is about rethinking enterprise context. And this is probably the first of several topics in and around enterprise context that we're going to discuss. And the broader message here is the fact that to get smart answers and to take better actions, smarter, faster actions, you need to have the complete context. And if you're a developer in this particular case, your context includes requirements, it includes incidents, it includes development metrics, but then it also includes what's happening operationally with the live services that you have running, serving your customers. Now, a lot of the information, the logs, the metrics, the traces, we call this melts inside our company: metrics, events, logs, traces. We believe that this information, if it can sit side by side with all this other information, you can make smarter decisions. You can have better proactive information. And of course, a lot of us who are doing a really great job of managing incidents and managing quality and reliability online, we already know this. But how do you turn this into something that is more operational, more AI native, and faster? Is a question that we've been asking ourselves. And Dhrumil, I know you've been thinking about this quite a bit, and you have a point of view here. So maybe you can just kind of introduce what you've done here.
Yeah. So I think with the melts tech stack is like, again, Ahmed introduced, right? This is like metrics, event logs, tracing. This is like what is it, the primitives of what observability does provide, right? Every system or every operational system working in servers or anything has this data emitting, and we need a way through which we can basically create a context out of this whole stack, like data, like what are my systems working on? Like if something is failing, how can I can basically easily debug it, like make it more AI native. I can basically see what is the current state of the across the systems, like from each server perspective to each user perspective. So that's what we are basically building with this Melts tech stack.
Outstanding. And if you don't mind, maybe we can share your screen. And I know there's a couple of dashboards that we can share here. So when we look at this dashboard, what I think is really interesting is, first of all, it may look similar to a dashboard that many of our viewers may have seen before. So as an example, you could probably have a Grafana dashboard, or maybe if you're using even a proprietary tool out there, you can see plenty of dashboards in the past. Different types of line charts, bar charts, tables, what have you. But what's really fascinating is not necessarily the table itself, but it's how the information inside the table is actually being generated. So let's talk a little bit about this. Like this first widget that we're looking at here, if we were to just kind of jump into this, Fastly Edge Compute P90, like tell me, how is this information being harnessed?
So I think this particular dashboard is generated from logs, right? When we
Yeah.
are ingesting logs from systems. So Fastly is one of the components which is emitting lots of data to our systems, where all the interaction or API interaction of system, like for a given user, what are the paths and how much P90 are we, how many edge latency we are facing for a given user. So this particular widget which we are seeing is a what we say the common P90 of per path. So, and the data through which is like not like a traditional tables. It's more of a tables where we have logs, which is like kind of unstructured data, right? And we have this fields like resource.path, dev IDs and everything, and the edge latency, right? So we use that data to basically plot that data and find the P90 trends among this. So if you find some anomalies in between, the CSMs or people can basically use that information to derive more context on the problem.
Amazing. And so, I mean, what I like about it is that this graph is basically a graph that's being generated not through specific metrics or gauges that we've instrumented, but it's actually being derived from just plain logs, just unstructured logs. I mean, semi-structured logs, and that's obviously not brand new. But the way this information is being, first of all, it's near real time, so it's like sub-minute latency. So, the lag between when the event is happening, when the log gets published, and when these widgets get updated, we're talking, tens of seconds, if not a minute or so. So that's fantastic. But I think what I find quite interesting here over the last several years, and how this contrasts with what we've seen earlier in sort of SaaS tools, is the fact that, over the last 10 years, OpenTelemetry has become a standard. It's become a standard for metrics collection. And I think that was great as a first step. But everything that's happened since then, I think if we kind of walk through that journey together, Dhrumil, I think that says a lot about how the opportunity we have in front of us to kind of combine this with the rest of the information, the observability within an enterprise, starts to become really exciting. So first technology I want to bring up is FluentD, FluentBit as a modern aggregation pipeline. Now earlier, you would have had to deal with multiple queues, have to think about head of line blocking, had to think about all sorts of problems in terms of the semantics of, did I count it once? Did I not count it? Did I count it twice? What have you? FluentD, FluentBit, how have they changed the game?
So I think Fluent is not a very new technology. It's like another olden technology only. So again, it was basically, it started with a very basic approach where just ingest into Fluentd, it will forward into multiple destinations, like probably move to Elasticsearch and S3s and everything. But we found out a new feature in Fluentd where you push them into Fluentd, and Fluentd has a very good buffering capabilities, right? So ingesting lots of data, you don't need a queue to basically ingest it. You can basically push to Fluentd, it will buffer them, it will move to memory to disk, and disk to again it. And then there is lots of architecture like consumers, right? Where within the Fluentd you can define a consumer. For example, for our use cases, what we did was, whenever we see a log, we ingest it, we basically buffer it for certain minutes, then basically push to an S3, convert them into Parquet, then push to S3. And we have another approach where we move the data to our indexers, the Tantivy indexer. Again, we'll discuss it later, but that's what the FluentD provides, right? It's a native buffer as well as native consumer producer architecture, which basically helps us to create them within a single system. So, and it's very scalable. So what we did was we took one FluentD and we basically created a cluster of FluentDs to ingest lots of data. And that helps a lot because we are kind of ingesting around terabytes of data per hour traffic. And this FluentD architecture was able to handle that load using local buffers, converting into memory to buffers, and doing that stuff.
Awesome. And so, and that makes a lot of sense, right? Because now you don't have to deal with sort of going from one queue to another, just aggregating things and having to deal with the buffering yourself. The other big sort of advancement has been sort of this idea of zero code observability. Now, obviously there's nothing wrong with instrumenting your code to have a lot of observability, but zero code observability, having information come directly from the system itself, that's changed the game as well, right? So eBPF, tell me about that.
So the eBPF is one of the new technologies where people are using kernel-based operations to manipulate data or get data, right? So for example, some of the use cases for eBPF were like using for network operations, but now people have figured out, as we can read network operations, we can do multiple things, right? We can get the profiling data, we can get the network calls, like for example, and we can also get the metrics of the local system, like what is my disk usage going on, what is my network usage going on. And that's where the eBPF layer comes in. You don't need to add libraries in your code. You can just define an eBPF working as a daemon set in your Kubernetes cluster and basically pushing metrics, pushing logs, data, and everything to the system.
And of course, the reason we're even discussing this in the broader sort of theme of enterprise context is because this stuff, it actually makes a material difference in being able to answer questions around reliability, safety, availability of a feature even, right? So, at some point, a developer or a product manager might be thinking about a specific service, microservice being down or being under duress or having errors, fatal alerts, what have you. But ultimately, these things are meant to serve customer requests. So to be able to, in a product organization, have answers that actually tie it back together, if this information is available, not just through graphs, but also available as a data set that can be queried at the same time that you're able to understand where you are with your sprint or where you are with customer sentiment. This stuff can really matter. So enterprise context in a modern world, if you can start to really summarize and index this information coming all the way back from the services that you're running in a way that's zero code, is really interesting. But I think there's one more piece to this whole thing. I mentioned indexing all this information, these logs, semi-structured logs. That's Tantivy. So tell me about Tantivy and the way you're using it right now.
So I think let's go with the backward of things. Like people were using the ELK stack, right? The elastic what is
Log
it, log,
stash Kibana.
Logstash and
Yeah.
Kibana for dashboarding. So the idea was for them was to ingest logs, put them into local disk, and then basically create this Lucene index for querying the data, right? But the
Yep.
problem with that approach was, again, because of using this disk for storing all this data, right? And because of this agentic world where we are like ingesting lots of data, like terabytes amount of data, you can just put into disk and expect that it will run, right? For infinite. The cost problems are huge, right? Where we are basically using EBS. Again, EBS is not cheap, right? And
Yep.
again, the availability, the concern due to availability, you have to basically replicate that data. So we basically started with a very different approach. Rather than putting everything into disk, we use S3, the object store for storing this data. So we basically pivoted from this Lucene-based, disk-based indexing to this object-based S3-based indexes, which uses Tantivy. So Tantivy is again nothing a new technology, but same algorithm like Lucene, but powered by object variability. Like we can push the Tantivy index to objects, and we can use what we say algorithms on top of it and to get the data. So it's like just in time index. I think that is
Yeah.
a very good way to explain that.
No,
So
you're right. I mean, there's a ton of advantage, right? I mean, first of all, I mean, between everything we've just talked about, it's 10 times easier to develop a metrics collection stack now. It's obviously 10 times cheaper because of the just-in-time retrieval, the fact that you're giving up your sort of block, your local volume, your EFS, and you're opting for an S3, which is obviously blob storage, way cheaper. And the way the cloud architecture is evolving in terms of network bandwidth and so on. This is a trade-off that you can make now that perhaps you wouldn't be able to make before. And even in terms of risk and availability, this is way more scalable. It's a shared nothing architecture. You can do all this with obviously significant time, money, and risk advantages. My what I think is super interesting is that for so many years, I mean, obviously cloud computing really spun off a tremendous sort of proliferation of services. And so there's, if you're in the world of SaaS, or if you're producing SaaS products, or maybe you are a developer, you understand that there's tremendous amount of logs out there. And most product managers, or maybe project managers, or maybe even leaders in the company, they wouldn't necessarily go and access these logs, not because they're not important, but because it feels like it's the person who actually instrumented the log, the person who actually published the log in code, is the person that would understand how to interpret this information. And it's the person that would know where to find this information. So it becomes a search problem, in the sense that the reason we are not having this information be a part of our answers is not because it's not a part of the answer. It's because it's hard to find this information. It's too difficult. It's too esoteric. You don't even know if it was instrumented into the code. I mean, just imagine how many times some engineering leader, or let's say business leader, had to say, hey, are we producing that log? Or is there a way, are we publishing that information? And nobody knows, right? Nobody knows is often the answer. And I think what we're doing here is by increasingly turning this information into a zero code metrics collection strategy, and having this information be coincident with the rest of the information in your business context that you have information around, that you have accessibility around. Now you're able to ask questions and get the right answers. You're able to get answers that are actually not just citing issues and maybe opportunities or cases or sprints, or things that are easier for you to reconcile, but they're also citing things that are coming from logs and metrics.
Yep.
This is, I mean, it's a way of really, tearing down walls, if as it were. I mean, there are some false boundaries in my mind around, let's just say, information that was programmatically being produced and information that was manually being produced and put into maybe a more accessible system of record. And now these false boundaries are being torn down.
Yep.
And I think, like, obviously we're showing this as a dashboard, but easily this information could also be accessible through a conversational meeting, right? Through computer. Tell me about that.
Yeah. So like we have seen lots of use cases going on. Probably I can demo right now, but I think it's like agents accessing this kind of logs and giving answers. Like for example, we have this MFG OPA agent which was running previously, which was like, give me access of all the security logs and basically identifying it, like what this particular user is facing problem. So this kind of logs, this kind of information can be in extracted out from this logs information and then help the users. So that kind of use cases have been basically pushed down in the melt stack as well right now.
And of course, you're showing me logs, but could you maybe switch to maybe showing me metrics as well?
Yeah, sure. I think this should be the metrics. Yes.
Okay, so these are metrics. I mean, it's a similar technology here. I mean, obviously, you're not having to do any kind of just-in-time resolution or indexing because it's just metrics. So here you've still got the same fluent D, but in this case, you're just going to propagate that and store it as Parquet instead of, which is a highly compressible format that you can store in S3. You don't necessarily need Tantivy here. But I think in this particular case, when you now want to go access the information, you're going to have it available in a DuckDB database, which is a fast analytical database that you can run in the cloud or on the machine itself. What I love about it is that either way, whether it's Tantivy or DuckDB, what's the takeaway message from my side is the fact that these technologies are, they're not new in the sense that they're only around for a year or two. So they've been around for the last 5-7 years. So they've been battle tested for the enterprise. However, what's really fascinating is that they're not just software solutions. They are solutions that are banking on hardware optimizations that have been made over the last 5-10 years. And that's what makes them so exciting, is the fact that just like we've seen huge advancements in, let's say, audio, video, encoding and decoding over the last decade, as we've seen sort of this proliferation of photos and videos in YouTube and Instagram and all that, we've seen similar, what I would say, parallel execution, where you run the same operations on a larger and larger set of data. And in order to do that, you need actual microprocessor changes. And so with AVX and some of these advancements, we've been able to do what we now call vectorized compute. And vectorized execution is exactly what DuckDB and Tantivy are taking advantage of. So tell me a little bit about that, like this high parallelization that these technologies that we're using offer that maybe the predecessors don't.
Yeah. So I think the main crux of this whole vectorized execution was like this SIMD architecture, where you have this single instruction which can access the multiple data, where you mentioned that AVX-based architecture, where now the AVX architecture can do 16 operations in a single instructions. So, for example, this instruction is very native, right? It can be like some mean, max, mean, do some sort of compression and everything.
Right.
But the ideology of you doing this native operations at a very parallelized approach, not from threads or language perspective, but from the CPU or the processor perspective, makes it more advantageous. Like, for example, processing terabytes of data, you can basically do a less execution now, because you can basically process 16 data points, converting them into 16 data points and then merging it, where the schematics of arrow schemas and everything basically use this SIMD architectures a lot.
Absolutely. So, I mean, just to kind of recap this, what we're effectively saying is that from, going from the inside of the machinery outward, what we're taking advantage of here, which is probably different than what most enterprise solutions do, at least, more of the older technologies, is the fact that we're taking advantage of this higher parallel vectorized execution that's coming through with AVX and some of these other technologies, and SIMD, as you talked about. We're also taking advantage of these new layouts that offer early data pruning and more aggressive disk projection. We're taking advantage of the fact that now allows us to actually store data in blob storage versus on disk or in memory, right? And of course, just over the last several years, we've seen faster processors and faster networks, and we're taking advantage of that as well. So the fact that you can store data in S3 is only allowed because networks have gotten faster. And also we have this ability to do more aggressive disk projection and data pruning. So when you do data pruning, you're able to transfer less information. That means you're able to offset latencies more readily. Better network bandwidth, better network capacity means that you can actually do this at scale. And of course, aggressive disk projection as well means that you can lay data out in ways that are going to be advantageous. And of course, faster processors and the vectorized execution means you can actually run the same compute over larger tranches of data, which really helps you do analysis more quickly and more in real time. So I really like, sort of how we've been able to coordinate all these technologies together to create an experience. And of course, going from the outside in, what we're really talking about is the fact that now zero code instrumentation allows this instrumentation to live right next to all the other business data that we've expected to have access to conversationally. And so for a person who's using a computer by DevRev, they could ask information like, where are we with our sprint? What are the issues that are taking the most time? And that's information that's coming from let's just say a highly structured source. Maybe if you're a Jira or a Linear user, you can get those answers, or maybe you're just using DevRev outright. But of course, if you want that information to also be governed by what's happening on the systems, by the machines, that information in the form of metrics and logs is going to be right there for you to get that information as well.
Yes.
And so that's great. I think maybe in a subsequent conversation, we should probably show what these things look like through computer. I don't know if you want to show that today, but I think one other topic that I did want to talk about today is how does this all connect back to the customer, right? Because I know our customers are getting excited about Agent Studio, which is going to be, the new way that they're going to be able to build an upskill computer in the future for their use cases. To get better answers and take actions on whatever it is that they're doing in their business. So tell me about how all of this new technology makes its way into Agent Studio.
Yeah, I think one of the main core crux of the Agent Studio was observing the chats and how it works with DevRev, right? So you can basically observe that how agent gets that data from that particular skill calls and everything. So the main idea was to get that whole trace for a particular conversation which we did with Agent Studio and get the data. So I think the ideology of using melts for Agent Studio was to get the traces ingest into the systems, and people can use that particular opinionated dashboard on Agent Studio to basically get the traces and visualize it, like why did my agent interacted with this particular way. So this is coming up. And another point which is basically coming with Workflow Studio and Agent Studio is we can now query that data and make it more observable. Like, for example, why did my agent interacted with this way when this issue was triggered, right? So this kind of observability is also coming with this new Melts tech stack and Tantivy things which we are doing.
That's amazing. And so, I mean, this really helps bookend the entire agent or upskilling experience, right? Because you probably want to observe how things are going before you take your agent live or your skill live. And you also want to take a look at things after you've taken the skill live, right? To see what's happening, what knowledge base, what capabilities are being used, and by whom and how, and so on and so forth, what that performance looks like. Are people happy with the skill? Are people happy with the results they get after the skill is being invoked? Or did that go down? And all of this is some combination of metrics, insights, console logs, what have you. And of course, everything we just talked about is geared towards taking those metrics, those gauges, those logs, and making them indexed, available to you just in time, so that you can actually do live observability before going live. And then, of course, post your skill going live as well, post deployment. So this is really fantastic. And I think ultimately what we're trying to do is, bringing it back to sort of the enterprise context story. I think what we're trying to do is say, how does more and more of this information, as we all become developers, right? In a world where, conversationally and through more UI experiences, we can all upskill the agents that we use day to day for ourselves, for our teams, for our organizations. We're all going to be able to access this new experience, and we're all going to be able to create these skills or leverage these skills, or maybe even just evaluate the use of the skills as we conversationally interact with these agents. In this new world, we have to make sure that the logs, metrics that are governing the performance and use of these skills and these agents, these things are not foreign, right? Because if we're all developers, then we have to have a more business ready, a more consumer ready format for all of this information. And so what we're saying is connecting all of these new technologies into our Agent Studio, which is now consumer grade, means that a person can actually conversationally upskill the agent to say, I want you to also do this, and have that be something that takes effect immediately based on some programmability that's offered through conversations. And of course, have that not only produce the results that you're expecting, but also have you be able to evaluate it to see how often it's working, what knowledge, what capabilities it is taking advantage of. And for you to be able to ask those questions conversationally and have access to what previously would have been seen as console logs or service level logs that were sitting in Datadog or some esoteric location where, as a business leader or product leader, you wouldn't necessarily even go. That all changes now. So whether you're in sales, support, service desk automation, it doesn't matter. You can actually upskill your agent, leverage the agent, use the agent, and then of course also evaluate the agent, and you have all that context for you.
Yep.
Amazing. So tell me, any other thoughts around this? I know we started off talking about how OpenTelemetry started to formalize things. We started to use the opportunities around faster networks, faster processors, and we ultimately got to these newer technologies where processing eventually, got vectorized and more parallelized. And so we used that as an opportunity to leverage these new technologies, Tantivy and DuckDB, in order to produce logs and metrics that could be accessible in near real time. And then what we did was turn that into a data set that you can use even conversationally. And by doing so and putting it right next to the rest of your business context, we are creating sort of the future, what we call enterprise context, which is computer memory. And computer memory has not just human observability, but also has observability around metrics, machines, services, and everything else. Anything else that you'd want to show me here?
I think it looks good now.
Okay. My last thing I want to say is, like, if you were to think about this information, like, how do we make sure that it is actually sort of accessible in a way that scales? So, like, when you start to think about this information, and I want to maybe go back to what we do with DuckDB, for example. So what we love about DuckDB is that it's an actual SQL database, and so when you run a query, you can actually run it using, SQL or PromQL, whatever the technologies are. And these languages are highly declarative. That means that any answer that you get conversationally can be properly cited and grounded in evidence. So when you ask a question conversationally, what computer is going to do behind the scenes is actually answer your question conversationally, but it'll also tell you how it got to the answer. And how it got to the answer is going to share with you in a very sort of easy to understand and provable way exactly where and how the information was got, where it was selected from, what type of information, what type of events, what type of logs, and then what type of filters or predicates or conditions were applied on top of the data in order to provide the answer that you got. And if you want to take that from your conversational interface and turn it into a dashboard like the one we see on the screen right now, you can do so. I mean, that's a game changer as well, right, Dhrumil?
Yep. I think what we are seeing in conversation and seeing in UI as well. So that's basically a mix of experiences which you can use.
Yeah. And I think this is probably a good time to mention, by the way, if you guys want to talk about any of the technologies that we've discussed, whether that's, the fact that we're using Tantivy and DuckDB, or if we want to talk about, SIMD or any of the other things that we've talked about. By the way, the fact that a lot of this stuff is coded in Rust is also helping with performance. But if you want to talk about the technologies, you can always find us on our Discord server. And we'd love to meet you guys there. We love talking shop with you guys. And I think it's also important to mention that Computer was GA'd this week. So Dhrumil, I guess Feb 9th, the day that Computer went live, and it's free for everybody. So if anybody's watching this and wants to try out Computer, they can try it out, right?
Yes, definitely.
Outstanding. Okay. Any other final thoughts? Like, where is this going? I mean, we talked about the fact that it's going to get integrated with Agent Studio. Are there other sort of advancements in terms of scaling this, or adding protections and access controls and multi-tenancy and everything else? Like, I mean, I'm sure you're working hard on this. Walk me through that.
Yeah, I think the major task which we are now figuring out is basically how we can basically make it more multi-tenant, right? People can use it, other DevOps can use it, and that's the ideology here. Make it more multi-tenant and more user friendly, like have workflow observability also using this melt tech stack.
Outstanding. So I'm looking forward to that, because I know we've been dog fooding this for a while now, and it's going to now become a part of our Agent Studio. We're going to start to test that locally inside our product. And of course, at some point, that'll eventually make it to our customers. So very exciting indeed. So with that, I think what we can do is look forward to maybe having you again in the weeks and months to follow, where we can maybe show this through a conversational demo, perhaps even show how it integrates with Agent Studio. So I'm looking forward to that. But in the meantime, it's been great using these dashboards to track information that's coming from our services. Some of it instrumented, some of it completely uninstrumented. And obviously, it's changed the way that we do our own incident management, the way we do our own service management, and track our deployments. And I'm excited to see how it all kind of fits together with Agent Studio and Computer in the weeks to follow.
Sure.
Awesome. Thank you again, and thanks everybody for joining us. We'll see you next week. Take care.
Bye-bye.
Bye.